Artificial intelligence, or AI, is a branch of computer science. It focuses on creating machines that can perform tasks that typically require human intelligence. These tasks include learning, problem-solving, and decision-making. AI systems are designed to mimic human cognitive abilities. Neural networks are a type of AI inspired by the structure of the human brain. They consist of interconnected nodes, or neurons, organized in layers. These networks process information in a way similar to our own brains. Imagine a neural network as a team of interconnected players passing a ball. Each player represents a neuron. The ball represents a piece of information. The players work together to pass the ball down the field to the goal. Neural networks are trained on large data sets. This training allows them to recognize patterns, make predictions, and improve their performance over time. Just like we learn from experience, neural networks learn from the data they are trained on. A neural network is made up of layers of interconnected nodes. Each connection between nodes has a weight assigned to it. This weight determines the strength of the connection. The input layer receives the initial data, like an image or a sound. Hidden layers process the data, extracting features and patterns. The output layer produces the final result, such as a classification or a prediction. Think of a neural network designed to recognize handwritten digits. The input layer would receive the image of the digit. Hidden layers would analyze the shapes and curves of the digit. The output layer would then predict the digit based on the processed information. Each node in the network performs a simple mathematical operation on its inputs. The weighted sum of these operations determines the node's activation. This activation is then passed on to other nodes in the next layer. Neural networks are inspired by the human brain, but they are not exact replicas. The human brain is far more complex. It has billions of neurons and trillions of connections. Neural networks are much smaller in scale. Similarities: both use interconnected neurons to process information. Both learn from experience and adjust their connections over time. Differences: the brain is a biological organ. Neural networks are artificial constructs. The brain is highly adaptable and capable of general intelligence. Neural networks are typically designed for specific tasks. Think of it this way: a neural network is like a simplified model of a single brain region. It captures some aspects of the brain's function. However, it does not replicate the full complexity of the entire organ. Despite these differences, neural networks offer valuable insights into how the brain might work. They also provide powerful tools for solving complex problems that traditional algorithms struggle with. Section 4. Learning and adaptation in neural networks. Neural networks learn through a process called training. During training, the network is presented with a large data set. The network adjusts its weights and biases based on the feedback it receives. The goal of training is to minimize the error between the network's predictions and the actual values in the data set. This is achieved through an algorithm called backpropagation. Imagine training a neural network to recognize cats in images. The network is shown thousands of images labeled as cat or not cat. With each image, the network makes a prediction. The error between its prediction and the actual label is used to adjust the network's weights. Over time, the network becomes better at recognizing cats in images. This is because it has learned the patterns and features that distinguish cats from other objects. Section 5. Artificial intelligence in action, real-world applications. AI and neural networks are transforming various industries. They are being used in numerous applications, including image recognition, identifying objects, faces, and scenes in images. Natural language processing, understanding and generating human language, such as in chatbots and machine translation. Medical diagnosis, assisting doctors in diagnosing diseases based on medical images and patient data. Self-driving cars, enabling autonomous vehicles to perceive their surroundings and make driving decisions. The possibilities of AI are vast and constantly expanding. As AI technology continues to advance, we can expect even more innovative applications in the future. Section 6. Conclusion. Summarizing the interplay of AI, neural networks, and the human brain. Artificial intelligence, particularly neural networks, draws inspiration from the human brain. While not perfect replicas, neural networks offer a glimpse into the brain's workings. They also provide powerful tools for solving real-world problems. Neural networks learn from data, adjusting their connections to improve their performance. They excel in tasks such as image recognition, natural language processing, and medical diagnosis. As AI technology advances, the line between artificial and biological intelligence continues to blur. This progress raises profound questions about the future of intelligence and our relationship with machines.